Hello, hello, hello. So it's time to renew our photogrammetry free photogrammetry software list from 2020 with a brand new one tailored for 2021. I think we will do 4. So I will kind of behind the scenes, I'll just get rid of all of the underperforming ones and I'll try to kind of just show you top 4 ones that I would pick, and then we will pick a winner. That's it. Let's begin. All right, then. So let's begin with Meshroom by Alice Vision. At least I think Alice Vision is making Meshroom these days. So Meshroom got an update from 2021. Honestly, I don't see any differences, at least any differences in the nodes or anything like that. Everything seems to be the same. Well, the nodes are prettier, but that's about it. And just a disclaimer, I'll be working with these programs as if I was totally a noob, a total beginner, and I'll just see the ease of use, for someone who's just getting into photogrammetry. So I have a few images that I took of my arm. Actually, my wife took the images of my arm, and I'll just take all of them and drag and drop them in here where it says add pictures, right? So that's easy. It's kind of doing the calculations and so on, trying to find the aperture sizes and whatnot, and trying to recognize what kind of camera was used. And the camera that I used was also something that a beginner would use. It was my phone. So the images themselves are not fancy, and it's basically just me, mango, and a bunch of pictures of me just holding the mango or touching the mango, I guess. So the trick is that you want to get as many angles as possible, right, of the object that you're taking. And I took pictures of the arm because I move a little bit in between each picture, which should pose a challenge to the photogrammetry software for it to be able to rebuild my arm in 3D. And also the lighting wasn't that great, so it's a little bit noisy. So it is going to be a challenge for every of these programs that I'm going to check. Also, just to note, the pictures that were taken, I didn't catch too many angles from the bottom of the arm, right? So there's going to be a little bit of a gap there, right? So that's also going to pose an additional challenge. How many pictures are there as well? Let's see. Is there a way of how I can quickly see? Yeah, here. It says here 47 pictures. So that's also a pretty low amount of pictures for it to use. Let's see how it does it. Where do we start? Well, we might as well start with the green start button right here, right? So let me press it and let's see how long it's gonna take. Oh my god. Okay, so it took more than an hour to calculate. I made some food, I took a bath, I changed clothes. I had to change the GPU. So integrated GPU just straight up didn't work with Meshroom. I had to use NVIDIA, my NVIDIA card with it. So that's not user-friendly at all. And also, it looks like it's not really showing me anything after it's finished, right? So this, for a new user, this would be super confusing, right? I just see a point cloud and I see some sort of like a camera array. So the first thing that I'm going to do is I'll fiddle around with the camera sizes. Well, by fiddle, I mean I'll just turn it down to 0 and kind of take a look at the point cloud here. Let's increase the size of the point. So from the point cloud, I can see that there is indeed my arm here, but other than that, like this is not even a dense point cloud. This is just structure from motion. This is like the crappy one. I can't see the good one, right? And I can't see the mesh, and there's nothing to choose here. So in my opinion, Meshroom just shat the bed completely with this new release. Can I just drag it here? No, I can't. Okay. Anyway, we can still get the mesh, and I can do that by just right-clicking on mesh filtering. I won't right-click on, or I can right-click on texturing. I can choose to open folder, and basically my mesh is here with the texture, right? So I'll probably just create a new folder, call it arm Meshroom, drag it in here. And I guess instead of opening it up here and looking at it here, I need to open it up somewhere else, which was not the case in previous versions. So Meshroom, boo. Let's open it in Rhino. So I'm using Rhino 7 for this, but if you're all about that free software life, you can use Blender, doesn't matter. And basically after importing the 3D model, this is what I have. A wonderful piece, you know, just beautiful, beautiful mesh. Let's take a look at it in rendered view. What the hell is that? Oh, okay, there's my arm. So that's not that bad, is it? Oh, yikes. Okay, so we need to kind of rotate it first of all to the correct place. Oh shit, it's all exploded. And I said I wouldn't swear. Okay, so it's not a single mesh, it's multiple pieces of geometry that are just exploded, which is not great. Actually, it's two meshes, so that's not that bad. Let me just do one trick. I won't explain what I'm doing, just trust me. Yo, trust me, bro. That should help out quite a bit with alignment. So, god damn it. Where were we? This is the model that we have. And the model has a texture, which is a plus, but I don't really need a texture, right? Because I'm probably going to try and rebuild this or make some sort of a, I don't know, let's make a bracelet. Let's make a bracelet for me. We'll see how well it fits, right? I'll 3D print it and we'll do all of that jazz. But basically, I can turn off mesh wires. I can turn off mesh wires and see the mesh for what it actually is without the texture getting in the way. And what it is not a pretty thing. My part of my finger is missing, for instance, and everything is super bumpy. And the bottom of my arm doesn't look like that, I promise. It's a little bit funky here. And also it caught like a whole, I don't even know what this is. Oh, this was the sofa. So it caught like the armrest of the sofa as well, which is whatever, I guess. That's fine. I can just select all of this and just delete. And hopefully that, well, we don't care. I'm just deleting it. So this is the shape that we have from Meshroom. I am tired and I really want to go to bed. So we'll continue on with other three after I've had some sleep. Alrighty then, a brand new day and a brand new program. So this is Agisoft, I don't know how to pronounce that, Metashape Standard Edition, 30-day free trial. So, you know, technically it's free and it has full functionality, only that it works for 30 days and then they ask you to kind of pay up $200. I still want to keep it in the list though, because I find 30 days to be plenty to get like 3-4 projects out and to actually see if you want to use that program. So let's get crack-lacking. Actually, I need to yoink myself right here so that I'm not in the way. So the procedure is kind of the same for every program like this. I just find my image set that I have, I select all of the images and I drag and drop them in wherever it lets me. So here. Bam, we have the images. And now I need to somehow start creating, well, start first of all finding pairs of images that kind of work together or match pairs, and then create a preliminary point cloud from them, and then create a dense cloud, and then mesh the dense cloud, right? These 4 steps, and also texturing, so these 5 steps, are basically main ingredients to any kind of a photogrammetry software. So knowing that and being a total noob, let's try and figure out where these things are and what to click on. Not here, not here, not here. Well, I do have this chunk 1 with 47 cameras. If I right click on it, there's nothing here. Okay, but if we go here in the top and we find workflow, wonder what that means. If I click on it, there's this option here, align photos. And also below, I can see build dense cloud, build mesh, build texture. Interesting, right? Just like I've been telling you. So let's align the photos. And I am not going to change anything here whatsoever. I'll just hit OK and hope for the best. God damn, this is faster. This is so much faster than the Meshroom program that we used. I will still stop this though and let it, no, wait, maybe not. I'll stop this and I'll let it run. There we go, it did its thing and it's complaining a little bit. Some photos failed to align. Please reset alignment for incorrectly aligned photos and rerun photo alignment. Okay, I will do that. But we already see the point cloud here, and okay, so the navigation is obnoxious. Yikes. Okay, the navigation is not that great, but we do see, a resemblance of my kind of the top of my arm and a little bit of my sleeve here, and the table itself. This is, by the way, just a preliminary point cloud, only 10,000 points. We'll have much more. Okay, let's see, how can we realign the photos? Or do I even care about that? Oh, so this one, for instance, wasn't aligned, right? It doesn't have the tick mark here. Can I align select or reset camera alignment? Yes. And then align selected cameras. And it didn't do anything. Okay, cool. Everything else seems to be in order, so it's just that one camera. I will ignore it and hope that it doesn't screw me over later. Okay, so next workflow thing that we will do is we will build the dense point cloud. Bam. Quality, high, of course. Advanced settings, I have no idea what these do. I just hit OK because I'm a beginner user. And yet again, let's pause the video. Okay then, that's super nice. It took only 265 seconds to do. So what is it, like 4 minutes, something like that? Meshroom took like 30 or 40 minutes to create the dense cloud. So that's an improvement for sure. We can't really see it though. Let's see if I'm able to find this here, and it's 6 million points, so that's a little bit more than 10,000. Let's see where we can find it. I assume these 4 points here and these 9 points here represent 2 densities of point clouds. So if I click on this, sweet. Okay, so this is the stuff that I want, and there are some weird things happening here, and I can already see that it's a little bit bumpy. But goddamn, look how much better this is than what we have. Well, okay, this is a $200 program. I can see that there are some mistakes, or not mistakes, but some missing information at the bottom of my arm, and that's understandable because we didn't take any pictures of the bottom of the arm. I was curious on how the program will handle that lack of information. Anyway, we have the dense cloud here. It's time to make a mesh out of it. So I just go to model. Nope, I don't. I go to workflow and I click on build mesh. Click on that. OK, press OK, and just let it run. Okay. 535 seconds. Not that bad. So wait, that's not 5 minutes. That's a little bit more than 5 minutes. Still, not an hour. Not an hour. So let's see. Last button right here. No, it's not. It's a button right here, isn't it? We press and we get a mesh. Ta-da! This is much better. This is much better than what we had. Oh, shit. Okay, so the bottom of that arm is not that great. Ain't gonna lie. But everything else seems to be quite nice, quite decent. Let's export this. Let's export this and open it up in Rhino and look at it right next to the Meshroom one. Or rather, let's not, let me do this. We will have the grand finale later. Oops. Grand finale is going to be later. For now, I'm just going to straight up export this as an OBJ, export model. Let me just create a new one, folder, Metashape, arm, Metashape. There we go. See that? Gives me a bunch of information that I can choose. I'm not exporting the texture, so I don't care. I didn't even build the texture in this case. I don't really care about textures here. Vertex colors, vertex normals, all of that I want. I want all of that, so I hit OK. Now it's going to save my model. And I believe, yes, it is going to be a 675,000 vertice model. So that's a lot of mesh vertices. But let's just see how we can work with it. Let me insert. No, I don't want to insert. I want to import. Yeah, import desktop. Let's find it. I don't remember how I called what kind of name I used. The shape. No, that's not it. Meshroom cache. Oh no. Oh no. Okay. This is getting ridiculous. Is it in Metashape? Yes, it is in Metashape. God damn it. Okay, so we just hit open. And we just hit OK. We don't care about that part. And now we wait patiently until it opens up. By the way, in Blender, it also will take a while for it to open up. I mean, goddamn, that's a million faces for it to kind of show you. So of course, it's going to take a while. There are different ways of how to reduce the complexity or the amount of faces, but it's not a tutorial about that. But we do have, oh yeah, we do have a model. And that model is a single mesh. That's what I want to see. Okay, let's orient this bad boy. Bam, bam, bam. Bam, bam. Hello? Shift? No? Shift? Oh, please. Bam. Here we go. Just have it here. Take a gander. We will take a closer gander once we've finished up with the rest. But this doesn't seem to be too shabby. I mean, yes, there is a bunch of noise here, but that's not that bad. That's my ring. And the mango looks tasty as well. That's, I wouldn't say that's bad. And this is how being me feels like. Wait. There we go. My point of view. Holding the mango. Anyway, I should stop. Let's move on to the next program. So as our third contestant, we have 3DF Zephyr free program, which this is the only one that I have never used before. So I am indeed going to be a noob with it, and we'll see how far I can go. Right, so let's begin. Right, same procedure. Where's my, oh god damn it, I need to open up my file explorer. Then find where my arm set is and get all of these images and drag and drop them in, probably here or here. I have no idea. Let's try here. New project. This will guide you through the process of creating a new project. The current project will be I probably don't want that, so I assume maybe I need to drag it in here in the bottom, or maybe I do need to create a new project. Let's try it here. Apparently I need to do this. Okay, so new project. The current project will be unloaded. Avoid blurred pictures. Yeah. All of my pictures are blurred. Cameras not correctly reconstructed will be automatically removed. That's nice. So it's basically out of sight, out of mind type of a situation. You can select to automatically compute the dense point cloud and the surface at the end of the processing. Okay, generation options. Compute 3D model after project creation. No, I want to do that manually. Additional options. Mask images. No. Check online for pre-computed camera calibration. Yeah. Next. Okay, that's my images. Cool. Next. Wait, what was that? Import pictures from video. You can take a video instead of images. That's good. This is good shit. I want this. I want to use this. I will be using it for quite a bit with the video option. Panorama picture option is whatever, but the video option is nice. Anyway, moving on. So these are the images that I have. It knows what kind of sensor I'm using, so it kind of understands that this is like a Galaxy Note 10, which is great. We just go next. Category. That is going to be a human body, probably, or close range. I'll go for human body. And presets. Fast, default, deep. I'll just go for default setting. Cool. Next. We just run it, right? We just run it. Oh God, my recording is lagging. I need to pause this. I need to wait. Is it that fast? No, wait. It's increasing in time. Okay, so I'll pause this and we will continue from there. Only took like a few minutes, but here we are, and reconstruction successful. Yay! So there's like one image that's not really working, and wait. Oh no, never mind. So this one's a no, and this one's a no, and last two are no's. Everything else seems fine. So 43 are being used out of 47. Yeah, fair enough. I'll just hit finish and let's see. So the sparse point cloud looks exactly like in any software that we have. Honestly, the navigation is much nicer. Oh, this is smooth. This is nice. And we see all of these little cameras floating about, and I assume I can, oh man, this is cool. I can click on images and it will show me what it got from the images. Why is there a pixel there? Can I delete it? Can I delete you? Delete? No, I can't. Okay, never mind. I probably can, but I won't bother finding it. I just want to see how they work for beginner users who would just kind of press on different buttons. So we have the sparse point cloud here. Let us figure out a way on how to create a dense point cloud. That was easy. I just click here. Bam. We will use all 43 cameras for sure. Human body, again, presets default, again, next, and we run. Bam. So the cool thing here is that it actually shows me my CPU, GPU, like all of my statistics, right? System info. Wait, is this anything that, no, nothing that I should hide. So it shows me my CPU clock. It shows me how much of my physical memory is occupied, how much of my disk is occupied, and also it shows me my wonderful laptops, GeForce GTX 1650. Not even a Ti. And you can see the temperature slightly climbing up, slowly but surely. By the way, what does, wait, no, that's not the temperature, that's the temperature. So it's in the 70s, that's fine. That's not really climbing that much. Anyway, let me leave this to calculate for a bit, and then we will look at how the dense point cloud looks like. Whippy! It's done. It is done. Dense point cloud generation, blah, blah, blah. You don't care. Let's finish it and let's look at it. And look how pretty this is. Still, the bottom part of my arm is, oh, messed it up a bit. The bottom part of my arm is still not that great and not a lot of information there, but this looks real promising. Is it possible to change? What's that? No, what's that? Mesh stereo point cloud uniform coloring. Ah, got it. So either the points have colors or they don't. They look kind of boring without colors, so let's turn it on. Yay, colors. So that's the point cloud, and how can I check how many points we have? Probably there is a way, probably. No, that's not it. Okay, this shouldn't be me struggling tutorial, it should be me generating 3D models and testing them out. So let's create a mesh. Workflow, probably 3D model generation, right? Yeah, let's go for it. 3D model generation. Wait, no, cancel. No, I want to create a mesh. Mesh, please, mesh. Okay, let's do mesh extraction then here under advanced. Mesh extraction, dense point cloud 1. Yes, that's the one that we're using. All 43 cameras. Yep. Human body, still a human body. Next. Run. Easy. Easy. There it is. There it is. And it's gorgeous. Well, it is something. Maybe not gorgeous, but it is something. And it seems to be quite nice. Wait, let's investigate this without any colors. Okay, there's no way that I'm gonna understand anything here. So for this we need to export it as well. I will not be looking at it too much. We will be doing that a little bit later. Am I lagging? No, I'm not. Okay. File, or here, export. No, wait, export textured mesh. That's grayed out. Oh no. Oh no. Can I save it? Or do I need to actually texture it? That's a Zephyr file. Let's see. I probably need to texture it, right? Generate and export enhanced mesh. Okay, I want to do that. Target triangles. Yo, dude, that's like 5 million triangles. Probably don't want that. Is it possible to... Let's do OBJ first, and let's do... I mean, do we really need 5 million? My computer can't handle 5 million. I'll do 1.5. I know that it's gonna mess with, the outputs, but I think it's gonna remove most of the triangles from the table either way because it's so planar. Let's just try 1.5 million. God damn, 5 million triangles. And here we just save it. I'm just gonna save it in the Metashape folder. I don't want to keep creating new folders. Zephyr, save. Okay, look at this beauty. Look at it. So Zephyr really likes to merge things around and kind of merge everything into one shape. And also this bad boy has an insane amount of polygons. We'll need to work with it to fix it. But other than that, beautiful, beautiful. We save it and we will look at all of them up close a little bit later, but we save this and we move on to our fourth contender. There we go. It's a brand new day and a brand new program. So we are going to take a look at Regard 3D as our last contender. And this one is, actually I talked about it in my previous videos, but just to touch upon it, user interface for this one is not that great, not that intuitive as for the other software that we use, but we're going to try it out nevertheless, right? So first thing is, if I just grab my arm set and I drag and drop it in, I try to drag and drop it in, it won't let me. That's the first hurdle that we have. We actually need to create a new project, and I'll just set project path to my documents, and I need to name it, right? So I'll just say arm. Just to save time, I hit OK. Already exists. Yeah, of course, because I already tested it out. So arm2, I just click OK. And now we have our project running. And now I do have this possibility to add a picture set. So I click on it. It will ask me to add files. Sure. I will find where my files are at. And I'll just select all of them and hit open. So it's going to load them in, and it's kind of recognizing what we are dealing with. And thankfully, it has, it is recognizing all of the necessary bits and pieces, like all of the necessary data from the pictures. That's great. We don't need to do any manual work there. So I'm going to call it arm set and just hit OK to load it in. So now I have it here. I can't really look at it. I can believe that there is somewhere where I can kind of investigate the pictures, but I don't really care about that. Instead, what I'm going to do is I'll compute the matches. I'll click on this, right? And then here we're presented with the settings, and this is where the user interface just falls apart. I have no idea. I mean, normal sensitivity sure sounds like normal. Keep on matching ratio sounds like normal. Classic. I mean, there's a bunch of different mumbo jumbo here. I don't care. I just hit OK, right? And it's now going to compute the matches. At least we get an output window, but as you can see, the console is just blanking out. It's just showing blanks, right? So I'll let this run, and we'll continue from there. Sweet. So we have this done, and it took 1 minute, well, almost 2 minutes to make. But now we have our matches, and I can kind of show, I can investigate how the matches look like if I show matching results. And basically here in the bottom, I can see all of the matches that it found. And is it possible to? Yeah, there we go. So it kind of shows me the points that it found between the images. Great. We have this thing working. Let me hit OK. And the next step that we're going to do is we will right-click on the matches, or we can just click here on triangulation, and we'll try to build triangulation. Yeah, sure. Again, a lot of questions that I don't know the answers to, so I'll just hit OK. Bam, an error. Right, so this error is something that has plagued Regard 3D for almost a year now, honestly. Since the last video I did, they kind of shat the bed, and we had this kind of bug ever since. So we can try to work around it. I'll just delete the triangulation and try again. We can try to work around it, and we can try different techniques and different options to make it work. For instance, I'll untick refine camera intrinsics. I hit OK, still an error. So I'll save the time and just say that it doesn't matter what kind of settings you use, it's going to give you that error, which is a bug. Well, at least according to the forum posts and the reply from the makers of Regard 3D. That's a bug, which makes this program unusable at this point. At least with my image set, my image set might be just too bad. So we skip over Regard 3D and call it trash for now. Maybe they will get their stuff together. Let's move on to actually evaluating the three models that we have. We have Zephyr on the left-hand side, we have Metashape in the middle, and we have Meshroom on the far right. So just looking at them, as you can see, the Meshroom one doesn't have a texture, or rather doesn't have vertex colors applied to it, which is not a big deal. We don't really care about that. But I will go to Arctic View just to make things a little bit cleaner and just to be able to understand, what's what a little bit better and to compare. So let's start with, where do we start? I guess we started with Meshroom, so let's look at Meshroom. So here, there's a bunch of bumps that we would need to deal with. It didn't create rebuild one of my fingers. Well, I would say two of my fingers. And the underneath portion of it is not that great, but actually not that bad as well. I mean, it's kind of fine. So what I get from this is that Meshroom, when it doesn't know what kind of geometry it should create, it makes a hole, right? It doesn't try to build it at all, right? So that's the algorithm that they use, and in some cases it might be useful, in other cases it's not. But just remember that Meshroom took like 5, 6, 7 times more than other two, right? So Meshroom, honestly, sorry, dude, but you have got to go. Way too long of a calculation time for something that is not spectacular. Then we have this bad boy here, Metashape. Even more bumpy, so it creates even more noise, but we can deal with noise, that's fine. There's a bunch of smoothing operations that we can do and so on to rebuild this into a cleaner version. But as you can see here, the quality is even lower than the Meshroom one. And keep in mind, we're dealing with default values, right? So there are tweaks to be made that will make this a better 3D model, but I want to work with it as a beginner. So, and also there's a bunch of crap flying around, right? So it's super sensitive to noise. It's basically super sensitive to noise and to kind of additional geometry just floating about. It's actually not that bad. Let's take a look at the third contestant, the Zephyr one. There are some spiky boys, there are some dents, but this is a much smoother surface, except here. And it looks like it's lower resolution, but I don't think it is. I mean, since it has less bumps, it looks like it's lower resolution, but I don't think that's the case. One thing to note is that here my fingers were completely messed up, while here I can kind of start seeing, the shapes emerge, and almost all, well, this one as well, almost all fingers are in place. The only problem that I have with Zephyr is that it really likes to blend things together, right? So the algorithm that they are using is different from the other two in terms of it blending everything or trying to merge things into one shape as much as possible. That is actually, for me, that's a benefit. That's good, because that means I don't need to deal with a bunch of holes or all over the place, but instead I have to deal with dents and to separate things manually. But that's easier than filling in a bunch of holes. So honestly, between these two, for my application, I will be deleting the Metashape one, and I will be indeed using the Zephyr one. Surprise, surprise, I guess. Right? So the next step is to actually make this mesh that is usable, right? What I care about is mostly this portion of the arm, right? I don't really care about anything else here in the 3D model. So what I'm going to do is I will speed this process up, but I will delete everything that I don't need, and I will reduce the amount of polygons that I have here. If I were to look at the polygons right now, there's a few, there's a few polygons that were created, just a few. So let's clean this up and get on with it. So here it is. Here it is cleaned up, and I also drew a few planes. I'll talk about that in just a second. But basically, I just removed a bunch of unnecessary bits and pieces that I don't need in the mesh, and also I reduced the mesh, the amount of polygons. So now we're at, where are we at? We're at 500,000 faces, which is reasonable. We can deal with 500,000. I think it was like 3 before. So these planes here are going to be for a bracelet that I'm going to do. And basically what I want to do is I want to have these planes here evading the spiky boys at the bottom of the arm so that I don't need to clean them up as much. I'm basically finding intersections. So I'm going to make a few sections through my arm, and I'm going to loft it. And for that, I'll use Grasshopper because I'm lazy in doing it with Rhino. So I'm just going to reference in my surfaces. By the way, if you have no idea what's going on, check out my other tutorials where I actually teach about Grasshopper. It's a really cool tool. I reference in the mesh. Let's actually hide all of this. Like so. And then we go to intersections tab and we find physical probably. So it works with mesh and it works with B-rep, but it doesn't work with mesh B-rep, I think. But it works with B-rep plane, mesh ray. Sorry about this. I just need to really quickly. We can use mesh plane intersections. That's going to work. So mesh comes in here. Surfaces, all of these surfaces are flat, meaning that the planes can be extracted from them. And what we get from this is these section curves, these beautiful section curves. So as you can see here, the section curves are not, this is not what you would expect to get from an arm. So what I'm going to do is I will bake them out back into Rhino, and let me hide them for a second, or actually I'll just delete them. And I will clean them up in Rhino wherever I see that it makes no sense whatsoever, right? So let me show selected. Let me just show the arm for a bit. This is what we're dealing with. And I'll lock the arm mesh so that I don't accidentally select it. And now we will kind of try to get rid of the parts. Oh, and vertex snapping should be turned off. We'll try to get rid of the parts which we feel like won't work, won't do us justice. So that part right here for sure is weird. I don't have that stuff going on there. So we do something like this. Or actually, maybe even better. Sorry about being all jittery, but let me unlock and let me hide this. And instead, let me lock these curves and draw on top of them. Right, so I'll create a new layer and I'll make that layer red so that you see what's going on, just like that. And I'm going to draw a curve on top of this of these guide curves, right? Make my active layer, just like that. And in this case, I will skip over, for instance, here, right? Like that, probably something like that, right? Now I'll kind of draw out the form and close it. And I'll do this for the next 3 curves. Okay, so there we go. There we have our curves. And as you can see, I've evaded some of the spiky boys and some of the dents with them, but there's still a little bit of cleaning up left to do. I will unlock my 4 initial ones, guys, right here, and delete them. And now I'm going to make this a little bit even more smooth by rebuilding them with a lesser amount of points. So let's try 10. That's a little bit too big of a gap for my taste. Let's try 16 points. Yeah, that seems good. That seems good. So we do 16 points, and we have our form here. Let me show all of the geometry and hide these, and I can still see that the curves are kind of fine, and they are only intersecting in the bottom portion of the arm, which is kind of sagging down. My arm is not sagging down that much, but we'll see it once we 3D print it, right? So let me hide this, and let's kind of work on it. Let's see what we can achieve. So here I want a bracelet. So it's basically going to be this kind of a loft here, right? This kind of a lofted shape. But I don't want the bracelet to be like that because I won't have any way of putting it on. So I'm going to make it out of 2 parts. And for that, I'm going to just let's go to the right view. Zoom selected. No, right view is bad. Let's go to front view then. Zoom selected. Yeah, this is better. And I'm going to draw a line, probably somewhere here. I'll make a section. Section. Oh my God, I can't write section. There we go. And I'm going to cut through these, enter with this, enter, and I get a bunch of points, right? When you cut through a curve, you get points. And I'm going to select my curves now and split them with these points. So now I have the top, and bottom, right? So I am going to probably, what do we do? Let us select these and loft the bottom portion. And you can see that now the loft is kind of nice. And there is a bump here. I don't have a bump there. If I had, I would be concerned, but we will let it slide for now. And oops, hide that instead. And for the top, we also do the same thing. Nope, we don't hide it, we loft it. Okay. If I were to check it with EMAP, oh my God, why are you so big? That's the form. EMAP. That's the form that we currently have. Looks neat. Looks nice, right? Starts looking like a bracelet. So now, since we are dealing with Rhino, we can kind of mess around with it a little bit more and find some sort of a nice pattern that we can put on this bracelet. So I'm going to create a rectangle here in the bottom, and the size of it doesn't matter, right? A rectangle, and I'm going to, inside of that rectangle, I'm going to create another one. This smaller rectangle here, I'm going to create a planar SRF, planar surface for this rectangle. Let's think. Let's scale it down a bit and make, let's scale it down a bit and make 2 more. No, let's not scale it down. My bad. Let's keep it as it is. And instead, wait, shit, sorry, I'm thinking. Let's just scale it down. Less thinking, more doing. Create 2 more rectangles or rectangular planes here, up from here to here, and from here to here. So now I have 1, 2, 3 rectangles and a large one. Actually, the large one I can delete. I'll redo it again later. I'll rebuild the middle one with more points. So 4 and 3. That's 1, 2, 3. That's going to be 4. I think that's correct. I really don't remember. I think we need 6. Let's try 6. Hit F10. That's the rebuild. That was the incorrect order. That needs to be 3. That needs to be 6. Hit OK. F10. Yeah, now it works. And what I'm going to do is I will basically take, I promised last time, rebuild 4 and 6. F10. There we go. So I'm going to take the middle 4 points right here right in the center, and I'm going to move them up like so. So I get this kind of a cool little shape going on that I can join, copy, that I can copy around. That. Right? Flaky boy. Cool. That works. That's cool. And maybe one more. No, that's too many. Delete 2. I'm going to fit this on top of this, so I'm just looking at the proportion. I think something like this will work quite nice. And now I need to create thickness for these bad boys. So I'm just going to select all of them, extrude SRF. I need to do that separately. Fine. We will do that separately for every surface. That's okay. And we extrude it up by some amount. I don't know. Probably these are going to be pretty thick, so I'm going to do something like this, right? Actually, let's make it more fun before we do this. So everything is joined up into one big happy family. I am going to use Cage Edit on it, and I'm going to choose bounding box. And here for the point count, the Z point count I don't care about, so we're just going to have 2. X point count. I assume this is X, so we're going to have 1, 2, 3, 4, 5, 6. So we're going to have 7, and here we're going to have 6. Should be pretty cool. Enter, and then we take. Oh my god, this is going to be quite sick. Then we're going to take the middle ones here, and we're going to push them in like so. Yeah, that's the cool stuff. And these get pushed out like so. So now when I look at it, it's more diverse. Actually, this was nicer. Yeah, this is nicer. And I can push this even further, I think. So we take these and push them in as well. See that? How does this look like? 1, 2, 3, 4, 5, 6. Yeah, this looks cool. This looks pretty sweet. I'm afraid that this will self-intersect, but that's fine. That's, it is what it is. So we are going to take these surfaces and we're going to place them in Grasshopper as a brep. Set 1 brep, and we're going to, or do we do it with a brep? Sorry, now I'm thinking to myself, we don't do it with a brep. We just straight up. Let's do it as a brep. Bear with me. Bear with me. We will make this work. So we reference it as a brep, set multiple, or set 1. We mesh it. So we create a mesh component, mesh brep. There we go. So now it's basically remaking it as a mesh, and you can see the topology is not that great, but I think with settings we can make the topology a little bit better. If we give it a maximum edge of, I don't know, 1. Oh, 0.01. Yeah, that looks a bit better, right? At least I think so. It's a little bit nicer. We can even go lower than that. 0.0. Let's do that. Ooh, it makes this thing a little bit of a mess. So now with the slider, let's find a place that works. I think this kind of a density, maybe even less. This kind of density works quite well, and then we do some welding. Perfect. And then we do some Weaverbirds offset mesh or let's go to Weaverbird, transform. Where is it? Thicken mesh. Yes, that's the one that we want. And this is pretty big. So let's do less, 0.1 for distance. Oh my God, I'm using such small numbers, 0.01. That kind of distance is still quite big. 0.05, I think, will, 0.005 will do the trick. This is why you need to. This is why you need to do scaling first. You want to work with correct scale, and then you do the design. I skipped that step. We'll need to redo it later with the correct scale. Anyway, we bake this out with layer 1 into layer 1, and we have our thicken mesh here. That doesn't look that great. We will unweld it. Now it looks better. Nice. And we will use what's the flow along surface, right? We need to use flow along surface. So for that, I need to create a surface underneath this. Bam, 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 bam. We have a surface here. And basically, I'm going to transfer this shape from a flat surface to a curved surface. So we do flow along surface. Select objects. I'll select this bad boy. Enter base surface, this bad boy, and target surface, this bad boy. And it goes inside. Okay, so we need to flip this around. And we try again. Flow along surface, this, enter from this to this. There we go. So now it looks like that. That looks pretty sick, I ain't gonna lie. And we're going to repeat this for the bottom portion. Target surface. Again, we need to flip this around and we try again. Oops, we don't flip the mesh. Flow along surface. From here, enter, or rather from here, enter to here. Motherfucker. Okay, let's try again. There we go. Finally. Took me a little bit. So as you can see, it's not really following the curvature anymore of the arm, but we don't really care. It's gonna look like this. Should be pretty sweet, a pretty fun little design that we have going here. Nothing too fancy, but just to check. And I can see that there are some things intersecting here that I don't really like. And actually, now when I think about it, we didn't do any tolerances for fitting, right? So I'm going to take this and I'm just going to scale it up by 1.03 by 3%. right? It's just bigger, right? Just to make sure that everything fits. And that there is a little bit of a gap here. And now for fastening, the way we're going to fasten this is I need to figure out, but I'll do that off camera. Here we go. That's the final design. We are going to use zip ties because I was thinking about how to fasten these guys together and whatever. We're just going to use zip ties and we'll see what happens. So it's kind of the same form. I just cleaned it up a little bit, rounded off some corners with Catmull Clark subdivision, but besides that, it's the same thing. So now we are going to set it up and get it ready to print. Oh, by the way, I also used these 2 points and I measured my arm as well to get the scale correct. Which is a very poor way of doing it. Usually you have some sort of a 2 points either kind of marked out on the body or somewhere near on the table, which you kind of can use as a ruler to scale things to proportion. Anyway, let's move on. I will copy these, I will rotate these, and now I will figure out a way on how to place these flat on ground. So I will probably just do orient 3 points. How the hell are we? No, it needs to be from the top. Okay, so orient 3 points. And it's going to be vertex snapping turned on. This point right here, let's say. Also this point right here. And also the third one is going to be this guy right here. Let's see these 3 points, and I'll just lay it flat. Good. Same thing for this one. And by the way, looking at how the waves are working, right? So that when it's printing, it prints upwards. So the waves are looking upwards, just so that I don't need as many supports for it to work. So it's the same thing for this one, orient 3 points. This vertex right here. Perhaps this one right here. This one right here. Okay. Bam, bam, bam. So we have these 2 shapes here. And let's just nest them in a nice way. Like that. Just double check the bounding box if it's actually if it actually is going to fit in my 3D printer. How wide is that? That's 10 centimeters. That's fine. It's going to fit, no problem. So we select this, we export this. Bam. Okay, desktop. I'll just call it. We use STL for 3D printing, but you already know that. STL, bracelet, save, binary, okay. And I'm sure that these are closed objects, right? Closed polygon mesh, super, closed objects. So now here, all we need to do is just need to get our bracelet and drag and drop it in. That's it. That's kind of it. There's my TiVo Tarantula, the old school 3D printer. We slice it up. We take a look at how long it's going to take. And yeah, I'll get back to you once it's printed out. Okay, so let's finish things up here. My hand is going numb, so I'll be pretty fast. This is how it looks like, right? And it's honestly, I would say it's focus. It's a pretty good fit, except for the parts that actually misprinted. The zip ties are not doing it justice for sure. I should have thought of a better solution there, but it kind of comes to show you that even with 47 kind of crappy phone pictures, Zephyr actually managed to produce a photogrammetry model that is, it's possible to use it for design, which is amazing in my opinion. So that is the program that I'm going to recommend to you. Thanks for watching. Bye.